Welcome to solverfy.
The 95% confidence interval for the proportion of smokers who have tried to quit within the past year. Well, the sample proportion is the number of smokers who have tried to quit divided by the number of smokers interviewed. So that's going to be 2,636 divided by 5,409. I'll take it to 4 places. That's 0.4873. The standard error of the proportion can be calculated. Well, I'll just go right to the confidence level. That's the sample proportion plus or minus the critical z times the standard error, which is the square root of p hat minus times 1 minus p hat over n. And so this is going to be 0.4873 plus or minus the critical z is 1.96 at this level, times the square root of 0.4873 times 1 minus 0.4873 over 5,409. The lower boundary, I'll just take it to 2 places, is going to be 0.4873 minus 1.96 times the square root of 0.4873 times 1 minus 0.4873 over 5,409, and that's 0.4740. And the upper boundary found by adding 0.5006. A 99% interval is similar to the part A, except we're going to change the critical z. So it's the same proportion. The critical z is now 2.576 at 99%. Everything else stays the same. The lower boundary found by subtracting 0.4698, upper boundary by adding 0.5048. The statement about the proportion, someone claims that the proportion is less than 0.5. With what level of confidence can make this be made? Well, according to it's really close to the 95%, and I'm wondering if my rounding is a little too precise. Because of the 2 choices, they could make that claim with 95% or less, and it really would be less technically because it's just at the 0.5 practically. Find a sample size necessary for the 95%. The sample size we need can be calculated by taking z squared times p hat times 1 minus p hat over e squared. And so at 95%, we use the z-score of 1.96. Plus or minus 0.01. You're going to use 0.01 for E. And p hat is our 0.4873. And I think for this, I'm actually going to use the exact proportion instead of rounding to 4 places. Maybe that's kind of where things are a little bit off. I'm going to use the 2636 out of 5409 in my calculation. Okay, so we have 1.96 squared times 2636 out of 5409 times 1 minus 2636 out of 5409 over 0.01 squared. And we need 9,598 people. For a 99% confidence, the only thing we change is the 1.96 to be 2.576. And we would need 16,579 in the sample.